Welcome to Tuesday Talks. In today's episode, we'll be diving into the exciting world of artificial intelligence, language models, and machine learning. Please note that the views, opinions, and comments expressed by our guest speaker and contributor are their own and do not necessarily reflect the official stance of Link Digital. Our goal is to present a diverse range of perspectives to spark thoughtful discussion. Viewer discretion is advised.
Hello, Yevhen. It's great to see you again. I'm Alex. I'm coming from Seekend side, from data management, and Yevhen is the AI ML specialist, engineer. He managed teams. If you saw our previous talk, so we are building up on this one. If you haven't, I genuinely advise it was a good start. So, hi, Yevhen. Cool to see you.
Hi, Alex. Happy to be here again. We had a quite interesting talk previously, so my advice to all of our audience to see the previous recording. And I hope this one will be interesting as well.
Right. Agreed. So first talk was future of AI applications, but we get to basics of how tokens works and so on. So today our topic is AI implementation challenges. We're revolving around data quality, metrics, automation, data standardization, these type of topics. So the first question would be, what are the common challenges organizations face when they're implementing AI in their data workflows? Or additional question, or maybe building up on this, would be, what's the best way to start with AI?
Yeah, so there might be quite a few challenges in implementing AI in your company or organization, managing your workflow. Basically, it's because you have to alter or make some kind of changes into existing data management pipeline, existing and I assume well-polished business process and workflows. So imagine you have something good and well-established, and you want to somehow alter this process with artificial intelligence, aiming to improve existing workflow. The risk here is that AI might not be as performant and foolproof after the first iteration of implementation as the current workflow. So it is good to have like a parallel AI pipeline implemented in parallel, not like rapidly replace your existing and well-established workflow, but let's design a new pipeline that will iteratively replace your existing workflow. And the most important thing here is we as engineers or as a business, they want and should have some sort of comparison metric between existing pipeline and AI pipeline. So this metric should give us an idea how good AI pipeline workflow operates compared to existing pipeline. Is this pipeline good enough to replace our existing pipeline? So metric is the key idea, and parallelization of the pipelines is a key idea here.
Thanks, Yevhen. Insightful. Talking about this metric, what it could be, if we're talking about a specific metric. So which metric could help me as a business owner understand if my new pipeline performed better than my previous pipeline?
The ultimate metric basically is financial metrics all the time. If you can boil down your other metrics into some particular number as a financial metric, it's super cool. But it's separate work at tedious error-prone. Not all businesses can do this kind of things. So usually as engineers, we start with a metric that deals with the quality of a pipeline, not the cost of operation, but the cost of operation is a really good metric, but the quality of operation. And this kind of metric might be, for example, output data quality. Quite simple and reasonable metric.
Okay, thank you. So what you're saying about what you told about these two pipelines existing and new with AI, it resembles a bit in code writing and deploying this code. It's blue-green deployments where you have existing pipeline, existing deployment pipeline, and you are making changes, and these changes go through the second one. And so you always can revert back to this blue state and green state and basically see which one sort of meets the acceptance criteria at releasing what you want to the production. So basically you can always switch back. This is the idea, right? This is the idea with what you're telling. Okay.
Yeah.
Thank you. From your time leading ML teams, what concrete metrics have you found most effective for measuring improvements in data quality after implementing machine learning solutions? So it's about metrics again, and metrics on measuring improvements in data quality.
We as machine learning and AI engineers, we're dealing with not only models, but with data. And data quality is crucial for developing suitable and well-performant models. And dealing with data requires a lot of preparations, transformations, cleaning, requires planning of storage for the data, different parentheses, place balancing, and so forth, so on and so forth. And from team management perspective, and even from a business management perspective, it's good to have data that doesn't require a lot of transformation. So we don't need to have spent a lot of time for cleaning data, put a lot of resources and effort to make a code that cleans, stores, transforms data. So the ideal data is data suitable for training as is. So here the metric is the time we spend on a data preparation pipeline. So improving the data, we could make this time smaller. That's my ultimate metric. Make the effort on managing the pipeline or data small.
Okay. So it's a clear signal, positive signal, if it takes less time to prepare data. Okay. Thank you. How can AI help bridge the gap between technical and non-technical data users?
Technical data users. Okay, I see. So we have users that use the data. And what's interesting here, we as machine learning engineers who use data as is, they have some code, some SQL, some idea of where the data is stored, how to access data via API or system call, whatever. So we keep our hands dirty with the code, I mean, to interact with data. And it's absolutely okay for us. But for non-technical users, it's quite difficult. We can't say, hey, dear user, here's some database you can connect here and take a slice of data and stare at about it on a huge amount of numbers, build a statistic on your own based on the data and make some insights. For non-technical users, it doesn't work like that. those non-technical users, for example, some business owners or users of some data management platform, for example, they're not technical. They can't write SQL or Python code or any other code to access the data. How can we bridge the gap? We could try to use GenAI and large language models to basically implement an interface that can digest a simple, plain user request. For example, give me a subset of images depicting people wearing red hats, for example. And a set of LLM agents could digest this input to assemble some SQL queries, do a dirty job, and get all of these pictures with people with red hats and show it in a user interface or dashboard or whatever.
It's an interesting topic which we touched, which are AI agents, because you have a lot of information on AI agents in LinkedIn feed, in news. It's claimed to be something new where the industry goes, probably not new for a professional. So agent has, how would you define agent? Does he have a specific task to accomplish? And then this agent shares this task in some repository, which can be accessed by other agents, or how it works?
So diving deep into details, you can find plenty of information about LLMs on specialized sites, about agents, the blog posts, Anthropic from Andream, and so on and so forth. Those posts more, and those answers are more significant and professional than mine. I will try to explain into non-technical terms. So agent is an agent, some entity that can do a specified task. For example, the task of translating one language into another. You can do it with ChatGPT. But you can incorporate this functionality into your application and call this functionality of translation based on some conditions. For example, two users try communicating with each other, and we might have some agents that can detect the languages of those users, get the text or spelling or pronunciation, and put this into a translation agent. Translation agent just translate the text and return back. So it's like a programming, but with LLM. We already had this kind of agent functionality back in the days when we had like a branching logic and some just applications. So it's like agents, just a complex application on top of large language models and their functionality.
Thank you. That's really valuable when it's delivered in when the explanation is delivered in simple terms. Cool. Moving on. How can machine learning improve data standardization across different sources?
Yeah, I see the problem. I have data from different sources. It's really a pain for data engineers to collect data from different sources and standardize all those data. For example, just a simple example, you have like sort of pipeline to get feed or comments from Instagram and comments from the X. They are structured differently, and the API calls for getting those comments are different. And you have two piles of comments from Instagram and from X. But somehow you want to store all of this information in a specific way, in a single database or warehouse or sort of. And to do that, you have to process all of these comments from different sources in a way that will match a single schema. So we could try again to use LLMs and agents to automatically map schemas from different sources. We could use those agents to remove duplicates, because usually duplicates, not in the comments, but in general, not only in the comments, but in general, it's not a good thing to have duplicates in your code, in your database, because training on the duplicates is not good for final model performance. And again, those comments in our example might contain different languages. So we would like to translate all these languages into, for example, English, a standard way to store our data. So we could use, again, some sort of large language model and agents to do this. So wrapping up this kind of long speech, it's a schema matching, remove duplicates, and automatic translation.
Okay. I like that you're very specific in the answers. Thank you, Yevhen. How can AI help automate routine data management tasks?
Yeah, data management is not really interesting task for machine learning engineers. We would like to train our models and build dashboards and make some insights based on data. But data management, we also would like, as machine learning engineers, to automate this thing. So the first thing that comes to mind is, again, already talked about this topics a lot. In any answer, I mentioned GenAI, retrieval augmented generation, RAGs, and AI agents. And we could try to solve the problem of automating these routines with these knowledges. So we have a lot of data. And the thing we want to have for the data is tags. So which data comes from which source, for example, it's a tag. Which language of the comment it is. It's a tag, for example. We would like to have some clusters of the data. Those cluster comments are positive. Those clusters of comments like negative. So cluster or ranking irons, for example, or some goods. If you'd like to filter, generate metadata, calculate data statistics, and do some processing of data in an automated way. So a lot of things you would like to do. It's, again, tagging, clustering, filtering, generation metadata. All of these tasks could be done with properly tuned LLMs and GenAI things, agents basically. But the one thing we can do with GenAI is basically version our data. So what I want to say, we have might have different pipelines for differently processed data, and this pipeline might change from time to time. And we would like to version the final data. This final data comes from the version 1 of a pipeline. This kind of data comes from the version 2 pipeline. So management of the data should come with a tool for data versioning. And it should come with like a separate tool we would like to have.
Okay. And versioning is important for data lineage, so you can track changes and you can revert back if needed.
Yeah, exactly.
Okay. Under which circumstances you would need to revert back when you discover that the new version performs worse than the previous one, or what could be scenario?
Yeah, it's you already mentioned one of the scenario. Some drop in the performance. It's always nice to have the track of the history of the changes. So the new one engineers, for example, in our team, could see what we've already tried to make our data better. So they won't come up with the ideas we already tried or waste their time in implementing some pipelines we already done and the result showed in some sort of version. The other idea here, we could try mix different versions of a preprocessing, for example. It's part of experimenting with the model, experimenting with a dataset structure, which might increase or again decrease. It's a matter of experiment. The final model quality.
If I got you correctly, some tasks can be automated and some can't. Why these tasks in data management? Why these data management tasks should be performed manually, but not automated with RAGs, with LLMs, with GenAI? And which are these tasks?
Mm-hmm. So the task we could automate with GenAI and large language model, for example, it's a tagging, it's a clustering data, it's a filtering data, so make the data cleaner. It's a generation of metadata, so it's enrichment our data with auxiliary data that shows some additional information about the data. It's like tagging, but more wordy, I would say. Some statistical calculation, but again, we could try to. It's better to calculate statistic with a proper code node, but not with GenAI and sort of preprocessing. That's the thing we would like to automate. And the thing we can't properly automate, at least as ML engineer, I wouldn't like to automate this step, is data versioning. Data versioning is a crucial step in data management. We know AI agents that can do like interaction with CI/CDs, with a Git, with they can execute some different commands like git add, git push, and something like that. But if the data is complex and the tool, as it is for data management and data version, is complex, it's better to have, at least at the moment of the development of LLMs, to keep this step manual. This step is not so hard as the previous one, so we definitely could do it.
Thanks, Yevhen. I'm done for today. It was a great conversation as usually. It's been a thrill to wait for this talk, and I'm super happy that it went well. I learned new stuff as usually. Looking forward to another conversation to wrap up our series and talking about AI. It was piloting. Maybe it can spring something bigger out of this initiative, but it's more like it's after you guys who are watching. If you would react, if you would give us a clue that you need more content like this, info like this, I will try to get Yevhen in front of you again. And I see that Yevhen is enjoying talks as well. What do you think, Yevhen?
Yeah, thank you for the invitation again. It was interesting, and it is interesting to talk to you about application of modern technologies for data management, data organization, data pipelines.
Great. Thank you for joining us on Tuesday Talks. If you would like to learn more about implementing AI solutions for your data management needs, visit linkdigital.com. call them AU. AU is for Australia. Thanks again. See you.